I hope you enjoyed your day off. Today we're going to talk about Newton's second law, and you should be somewhat familiar with it based on the lab from a couple class periods ago and from the video. I'm going to hit some of my high points, things that you should make sure that you know. Newton's second law. When you did your lab, you should have come up with these two graphs, acceleration versus the force that it's applied, and acceleration versus the mass of an object. So let's say that I have the box, it's always a box. Let's say I have a box and it has some mass m and I apply some force to it. In this case, the mass is constant, and this isn't just any old force, though. This is the net force. And what that means is if I'm going to draw a free body diagram, then I have my applied force, like the push, and I have my force of gravity, and I have my normal force. The force of friction is going to go backwards. Remember, the net force is the total force, so that would be the applied force minus the force of friction, not just the push. As the net force on the object increases, the acceleration increases linearly. If I were to make this mass smaller and smaller and smaller and smaller, the acceleration will decrease, and this is an inverse function. It's not a linear function, it's an inverse. And so we can say that acceleration is proportional to the net force, and it is inversely proportional, 1 over m, to the mass. And that is basically Newton's second law. We can put these two things together and say that acceleration is the net force over the mass. Now, if we were in class, I would have had you do this real lab, and you could have found out from the slope of this line that the slope of this line is actually 1 over the mass, right? Because if you have acceleration versus force, 1 over the mass should be the slope of this line. And if you were to linearize this, then the slope of that would be the net force. That's sort of a tricky thing to do. Anyways, that is Newton's second law in a nutshell. Sometimes, or probably more often, you're going to see it this way: F net equals ma, or the sum of the forces is mass times acceleration. I think this is probably the way that I'm going to write it most often, but as we're talking about acceleration, the acceleration is what changes when you change how you push something or you change the mass of it. And so I like to sort of see it like this, because acceleration is often the thing that we measure in an experiment. So the big takeaway that I want you guys to know is that unbalanced forces cause a change in motion. Again, unbalanced forces cause a change in motion. This is basically Newton's first law, right? An object in motion will stay in motion, an object at rest will stay at rest unless acted upon by a net external force. Okay, I think net force is somewhat familiar to you, but what does it mean to be external versus an internal force? If I were talking about a bicycle, I'm going to pause and draw a bicycle real quick. Okay, it literally took me 5 minutes to draw this terrible bicycle. I'm so sorry. So if I were to draw this bicycle, and I were to give this bicycle a push, like a dad would be pushing and holding on to the bike as a kid would pedal, that's an external force, right? But internally, the wheels are pushing on the hubs, and the person, if you have a person on here, he's sitting on the seat, and there's tension in between all of the joints of this bicycle. Those are all internal forces. And so external force just means that it comes from the outside. Okay, so what does this really mean in terms of Newton's second law? Unbalanced forces cause a change in motion. So if the sum of the forces does not equal 0, then we will have some sort of acceleration, and that is the change in motion that we're talking about. So let's go back to this idea of a box, right? And we're gonna look at this form of the equation. So if I have a box and it has a mass of m, and I give it some push with some force F, it will have an acceleration of a. Now, what happens if I push it with 3 times the force, right? If I made this force 3 times bigger, well, the acceleration would also increase by 3. So if the force is 3 times bigger, then the acceleration will be 3 times bigger. But what happens if I took this mass and I made the mass of this object 3 times bigger? Well, just think of pushing a heavy person versus pushing a light person. You give them the same force. The heavy thing will not accelerate at the rate that the light thing will. And so if I have 3 times the mass, then my acceleration will be 1/3 of its original value.